Imagine a storm. Not a storm of wind and rain, but one of pure energy and matter, a tempest unleashed from the surface of our own star, the Sun. This celestial hurricane travels across the vast emptiness of space at incredible speeds. It carries the power of millions of nuclear bombs exploding all at once. This isn't science fiction, this is a solar storm, and it can reach out and touch the worlds of our solar system, including our own. We drift through the cosmos on a pale blue dot, seemingly safe and sound. But we are constantly bathed in the energy of our parent star, a relationship of both creation and potential destruction. The same sun that warms our world and gives us life also possesses a violent, unpredictable nature that shapes the destinies of planets. These cosmic outbursts remind us that the space between worlds is not empty. So what exactly is a solar flare? Picture the sun not as a smooth, perfect ball of light, but as a dynamic, turbulent ocean of superheated gas called plasma. Within this plasma, powerful magnetic fields are constantly twisting, stretching, and reconnecting. Think of them as immense magnetic loops, thousands of miles high, arching over the sun's surface. Sometimes these magnetic field lines become so tangled and stressed that they suddenly snap. This sudden release of magnetic energy is what we call a solar flare. It is an explosion of unimaginable scale. A large flare can release the energy equivalent of billions of 1 megaton hydrogen bombs detonating all at once. When a solar storm heads for Earth, we are not defenseless. Our planet has a remarkable two-layer defense system, a cosmic shield that protects us from the worst of the sun's fury. Generated by the molten iron core churning deep within our planet, this magnetic field extends far out into space. When these energetic particles collide with the atoms and molecules in our upper atmosphere, creating one of the most spectacular natural phenomena on Earth, the auroras. In March 1989, a severe solar storm induced currents that overloaded the power grid in Quebec, Canada, plunging the entire province into darkness for 9 hours. Now let's travel to our neighbor Mars. The red planet presents a very different and cautionary tale. We see ancient riverbeds, deltas, and lake beds carved into its surface. These features tell us that billions of years ago, Mars had a thicker atmosphere, was warm enough for liquid water to flow freely. Unlike Earth, Mars lost its global magnetic field about 4 billion years ago. Without this shield, the planet was left exposed to the full, unrelenting force of the solar wind. To investigate this very mystery, NASA sent the MAVEN mission to orbit the red planet. MAVEN has directly observed atmospheric gases being stripped away into space. First stop, Mercury, the closest planet to our star. For Mercury, solar flares and CMEs are not just an atmospheric event, they are a surface event. Next, we visit Venus, Earth's other neighbor. Venus is a paradox. Yet it has the thickest, densest atmosphere of any rocky planet in our solar system. Venus's dense blanket of carbon dioxide creates what is known as an induced magnetosphere. Venus is still losing parts of its atmosphere to space, especially lighter elements like hydrogen and oxygen, the components of water. Let's now journey to the outer solar system, to the realms of the gas giants. Jupiter in particular is a king in its own right. Its magnetic field is the most powerful of any planet in our solar system, nearly 20,000 times stronger than Earth's. It creates a magnetosphere so enormous that if we could see it in the night sky, it would appear larger than the full moon. When a powerful CME sweeps past Jupiter, it can compress this giant magnetic bubble, triggering intense auroras at its poles. These auroras on Jupiter are hundreds of times more powerful than Earth's, and emit light not just in the visible spectrum, but also in ultraviolet and X-rays. Saturn, the ring jewel of our solar system, also possesses a strong magnetic field and experiences its own beautiful auroras. Uranus and Neptune, the ice giants in the farthest reaches of our solar system, are more mysterious. From the scorched surface of Mercury to the strange tilted poles of Neptune, we see the sun's power in action. Solar flares and the relentless solar wind are not just curiosities, they are fundamental architects of the solar system. The existence of our vibrant biosphere is a testament to the effectiveness of the invisible shields that protect us every second of every day. This journey reminds us of the delicate balance that makes our world possible. When we see the auroras, we are not just witnessing a beautiful display of lights, we are seeing a physical manifestation of our planet's life-sustaining defense system at work. In the fate of Mars, we see the importance of our magnetic field. By understanding their stories, we gain a deeper appreciation for the precious and perhaps rare nature of our own habitable world. We are travelers on a small, protected spaceship, and it is wise to understand the space weather through which we journey. It connects us to the rest of the cosmos, reminding us that we are not separate from the universe, but an integral part of its grand, ongoing story. So, the next time you look up at the sun, please don't stare directly at it. Remember the immense dynamic power churning within. It is the source of our life, our warmth, and our light. The cosmos is both beautiful and dangerous, and we are right in the middle of it.